This video is part of a short series about Intelligent Practice, our online adaptive practice service for high school mathematics and science. In this video, we'll take a closer look at the technology behind Intelligent Practice. As such, it might be of interest to you as a new or potential user of the service, or even as an accomplished learner or teacher who has already been using the service for some time. Alternatively, maybe you are interested in licensing various components or combinations of our technology. We hope you find this useful. By way of introduction, Intelligent Practice is a software service that allows you to practice a vast number of mathematics, physics, and chemistry exercises. You can capture your answer even if it includes more complex notation like fractions and formula, and get checked instantly. Plus, the system will produce a fully worked solution to match each and every question, providing you with immediate, detailed feedback when you can most benefit from it. What really sets them apart, though, is the fact that those questions and their answers are generated automatically. This is no ordinary question bank. Each question is actually an instance created from an exercise template. Each exercise template is built around one or more central concepts, but the components, including images, quantities, and scenarios, vary with each attempt of the exercise. To break it down further, the parameters of how a question can vary are controlled in a Python file. The structure of the question is defined in an XML file. Put together, these bits of code can generate different versions of the same question. Think of it as a computer program within a computer program with the sole purpose of generating pedagogically sound practice items, heaps of them. Our EdTech production team at Siyavula carefully create each exercise and program in the parameters of these variables so that the questions and their solutions are not only accurate, but also make real-world sense. In addition, behind Intelligent Practice is a machine learning engine, adapting each practice session to the needs of an individual learner by changing the difficulty of the questions they see. That is, to ensure that practice has a significant effect on learning, the practice learners do needs to be at an appropriate level of challenge. That means practice should neither be too difficult, otherwise learners struggle too much, become frustrated, confused, and possibly give up, nor too easy, otherwise learners become bored and are not pushed to improve. The goal of the algorithm, therefore, is to maintain an optimal cognitive load so that learners, on average, get exercises right 70% of the time. The more they practice, the better it is able to estimate their ability. As learners progress and master concepts, the algorithm adapts so that they can move through more difficult levels. Our team of educational technologists are also creating extensive, sophisticated concept dependency maps for mathematics, physics, and chemistry, which will be built into the way Intelligent Practice sequences questions. Really, these maps look like this. They are highly detailed and enormous. But that's a little intimidating, so we prefer to use this simple graphic when we explain how they work. Essentially, these curriculum-agnostic maps construct a hierarchy of concepts, facts, misconceptions, and special cases, with dependencies between nodes and groups of nodes. They plot what prior knowledge you would need in order to reasonably be expected to understand the concepts tested by a particular question, as well as the things you might struggle with. To get a better understanding of how the concept dependency maps work, consider how your own learning path might look. You start up here and learn this concept. Once you've understood that, you have the basic knowledge required to learn this or this concept. Say you master this one next. You can't yet be expected to understand this one, but you could move on to tackling either of these next. Except with this one, there is a catch. In order to learn it, you need to have already covered both this concept and this one. So if you haven't done that yet, you should probably move on to this concept next instead, and so on, through the whole map. So we've got the concepts and their dependencies mapped out, but how will they fit into Intelligent Practice eventually? To better understand where the maps will integrate, let's unpack how this engine sequences questions currently. We've got a bank of generative questions, which cover a range of difficulty levels, And we've got you, our intelligent practice user. The engine behind intelligent practice measures your ability based on how you practice. We call this measure your level of mastery. Using what it knows about available difficulty levels and your mastery, the machine learning algorithm can sequence which question intelligent practice should give you to try next. It works like this. You get an exercise to try, you answer it and either get it right or wrong. Based on that, the engine adjusts your mastery level. Remember that that is its estimation of the difficulty level you are likely to get right 70% of the time. It's aiming to keep you in your zone of optimal cognitive load. Using your new mastery level, the system will then determine the level of difficulty from which it will pick your next question. Taking that, plus things like recency, or the last time you saw a particular type of question, and ideal frequency, or how many times you should see that type of question, the machine learning engine sequences the exercises you should see and gives you an exercise to try. Once we've integrated the concept dependency maps into the machine learning algorithm, it'll also be better able to establish what concepts you need to have covered in order to handle a particular question, and not just how difficult the next question should be. So in this way, intelligent practice works to keep you at your optimal cognitive load and seeing the most relevant sequence of exercises to help you learn. A record of each exercise you attempt and its supporting data, such as whether you got it right or wrong, or even what time of day you were completing the exercise, is then kept, and some of it is reflected back on your learner and teacher dashboards. On these dashboards, which can be easily accessed from the Intelligent Practice platform, are a variety of charts and other data presentations, so you can more effectively manage either your own learning or your teaching support. But when aggregated, this data can become even more valuable. For example, we can look at which topics have been completed when, by all our users, during the course of the year, or we might want to review the year's practice history for a particular class, a school, a collection of schools across a province, or even nationally. We can even review the time of day practice habits for a particular cluster or type of user, such as private versus public schools. In this way, such data can be valuable for a variety of stakeholders, from heads of department to government officials. In terms of the technology behind intelligent practice, we also embrace open web standards so that we are building future-proof solutions. We avoid the risk of platforms dying like Flash or Adobe Air, maximize our access to innovation, and support everything from a feature phone to a smart device to a PC. Our software is built as an online service, meaning it can be accessed from anywhere on any web-enabled device, with automatic upgrades and continuous addition of new exercises and features happening without installation headaches. And there are also automated backups, reported issues are responded to by our team, and no servers are required. In this way, we can maximize our reach to learners and teachers in South Africa and around the world by constantly building technology that is far-reaching and inclusive. While access to computers may sometimes be limited, mobile phone penetration in Africa is high and provides the content's primary access to the web. We pay careful attention to making sure our book content in intelligent practice can therefore be accessed from even the most basic internet-enabled mobile phone, as well as provide a truly world-class experience for the most advanced smart device. Our team of technology, content, and instructional experts have helped build intelligent practice, with its primary aim to be an interactive, engaging, and innovative learning experience. Driven by an adaptive learning engine, intelligent practice offers effectively unlimited exercises targeted at an appropriate level of difficulty, with immediate detailed feedback for learners when they can most benefit from it, and the ability to track your progress. That's it for our introductory video about the technology behind intelligent practice. For more information about the cognitive science and research behind our learning experiences, please also look out for our other video. Thanks for watching. Start practicing today.